Hello class, we are talking transformations. One last video here. Again, this is how we move a figure, change it. Four basic transformations. We got translations, just a slide. Reflections, that's a flip. Rotations. And dilations to make something bigger. All right. Now, what we're going to do today is we're going to talk about compositions. This is where we're going to take two or more of these transformations and we are going to put them together, right, to do something more complicated. Now these first three transformations right here, the translation, reflections, and rotations, these are called rigid motions. And the thing about rigid motions, what this means is that the image is congruent to the pre-image. So as I move my hand across the screen, it doesn't change, it's still congruent to itself. And I can move it, I can rotate it, I can flip it around all kinds of places, and it doesn't change. So you can take lots of different rigid motions, you can put them all together, and you're still going to end up with a rigid motion, right? Because if you do something that's congruent, and then you do something that's still congruent, and you do something that's still congruent, your end product is still congruent, right? So I can put all of these together in any way I want, and it'll still be congruent. Rigid motions. Dilations, however, not rigid, because the dilation changes the size, so it's not going to have, the pre-image will not be congruent to the image. All right. So when we're doing this, I am going to do these in Delta Math, so let me pull that up right here. Okay, so what we want to do is we want to determine a series of transformations that would map polygon A, B, C, D, E onto polygon A prime, B prime, C prime, D prime, E prime. All right. So we want to take the pink one and we want to move it over here to the blue one. So we're going to do a couple of things here. So first off, let's see, we want to get it in the right orientation. We want it facing the right way. And looking at this, that looks like we are going to want a rotation. We want D to rotate up to the top. So we'll do that. We'll find a rotation of how many degrees? And see, it's specifying counterclockwise, because you always do counterclockwise unless it says otherwise. Alright, so we're going to rotate it up like this, so that looks like it'd be about 90 degrees. So we will go with a 90-degree rotation. Now, when I do that, that is going to put D up here, right? Let's see, we're at 6. So we're at 9, 6. If I rotate it 90 degrees, that's going to put it at -6, 9. So that'll put it right here. And it's in the wrong spot. We've got to move it down. Should be in the right order, but we've got to move it down. So that would be down. Let's see, from 9 to 1, that would be a translation. We'll move it down 8 units. All right. So let's try that, see if it works. And there it is. So that works. It's good. You are correct. You may now press submit. I am not going to press submit because I want to look at some other things. Okay, so what I'm going to do, I'm going to refresh. So this was a rotation 90 degrees counterclockwise and then a translation 8 units down. I want to show you something else. So same question, but we're going to put that transformation in a different order. So what we're going to do here, instead, let's do the translation. And then see, we said that was down 8 units, right? So down 8 units, followed by a rotation of 90 degrees counterclockwise. And if I do this, it does not put it in the same place, does it? So the order matters. All right? We have to do the rotation of 90 degrees first, and then we do the translation down 8 units. If you do them differently, you get, it doesn't work. You got to do them in the right order. So we do this again. See, we have the rotation, and then the translation, and that works. Okay, so let's take a look at this one. This one, we want to map A, B, C, D onto prime, A prime, B prime, C prime, D prime. So let's see, it's facing the wrong direction. Let's get it facing the right direction. Looks like we would need a reflection for that, right? I was just going to take it and flip it over. If I reflect it, it will be, it's too big, isn't it? We need to change the size. So we need a dilation, and this one looks to be half as far from the origin. We're always going to want to do our dilations from the origin. That makes it a lot easier. Yeah, so this is a 2, 4, and this one's at -1, -2, +2. So this one is half the distance from the origin. So we want a dilation. It's half the distance, so scale factor of 1/2. And we also want a reflection across the y-axis. So let's see here. Let's go ahead and put the reflection in first. So reflection over the y-axis followed by a dilation with a scale factor of 1/2, and see what happens. And there it is. That works. That's great. Now, I am not going to hit submit on this one. I want to test it. What happens if we change the order on this one? So let's see. We had a reflection over the y-axis and a dilation with a scale factor of 1/2. Okay, so let's try it if we switch the order. So what happens if we do the dilation first? So dilation with a scale factor of 1/2 and a, what else do we do? The one was a reflection over the y-axis. So it's the same thing, we're just changing the order to see if it works. There's the dilation and the reflection, and that works. So you see, with dilations and reflections, it doesn't matter. You can do them in whichever order, and you get the same result. With the one we did before, with the translation, the order mattered, right? You had to do the translation last. All right, so let's try one more. Okay, so let's try this one. See, A, B, C, D is the big one. We're going to go to the little one. So we're changing sizes, so we need a dilation. And let's see how much for dilation. This is, how long? 1, 2, 3 units. This is only 1 unit, so I need a dilation of 1/3. Okay, so dilation, scale factor of 1/3. Let's see. Will that put me in the right spot? Probably not, because it says do something else, right? Okay, so that's going to be, where will that be? That's going to be closer to the origin, but then it's up above the line and not below it. Let's see. So 1/3 makes it 1/3 closer, which is going to put it right here, I believe. Let's find out. And then I think we need to translate it up. So translation up 2 units. Let's try that, see if that works. Yeah, there it goes. Okay, so now, so that was a let's see, dilated, scale factor of 1/3, translated up 2. Let's see what happens if we switch the order on those. Okay, so it's dead. Let's do the translation first. Translation up 2 units, and then we had a dilation from the origin with a scale factor of 1/3, and let's try that. That didn't work, did it? So again, if we did the translation first, it put us in the wrong spot. Okay. So key here, always do the translation last. First, get it the right size, then get it facing the right direction, then put it in the right place. Or if you want, you can put it in the right, facing the right direction, then we get it the right size. Let's try we did a reflection, let's do this. Okay, so let's try this. We need to get it over here. Let's see, we got that. Looks like it's a rotation. We're going to spin it around, but it's the wrong size, right? Definitely got to make it smaller. Let's see, this side is 3 units. This side is 6 units. So AB is 3 units. A prime, B prime is 6 units. So we need to double the size, right? Because remember, we go from the A, B, C, D, E to A prime, B prime, C prime, D prime, E prime. Okay. So we're going to get it the right size first. So dilation, scale factor of 2. And remember, that's going to move it away to, so this -2, +2, doubled will be -4, +4. And that's also on -4, -4. So this will be a rotation with a scale, rotated 180 degrees. See if that works. Yeah, there it is. Let's see, can we change the order here? let's see here. So let's change the order. Let's do the rotation first. Rotation 180 degrees, followed by a dilation with a scale factor of 2. And see if that works. There's the rotation. And there's the dilation. That works. So, pretty much you can take all of your transformations and put them in whatever order you want, except for the translation. Always do the translation last. Otherwise, it throws things off and it's not going to work. It's a lot like order of operations, right? First, you want to multiply and then you want to add. Notice, look at all of your rules. The rules for reflection and rotation and dilation, those are all kind of a multiplication rule, right? But the translation, that's adding and subtracting. So you want to do your multiplication, you want to do reflection, rotation, dilation first, and then you want to do the translation. Okay, so let's look at this. What we want to do here, we want to find the image of this point after the transformation. And what this means, we've got the d with 1/2, that means we want a dilation with a scale factor of 1/2. T, 2, -1, that means we want a translation of 2, -1. Now remember, order matters, right? Especially with those translations. Now, what order do we do them in? Well, this circle right here, this means of, all right? So this means we want a dilation of the translation. So the translation comes first, all right? Because we want to do the translation and then take a dilation of that. So anytime you do this, you want to start with the transformation on the right comes first. So this comes first, then we do the dilation, all right? So that's a little weird. It kind of looks like we're doing it backwards, but that's the way it works. So first we're going to do the translation because that's the order that we have it in. Remember, I'm always going to go from the right on these because it's weird. So first we do 2 - 1 for the translation. Remember, all we do is we just take that and we just subtract that vector, or add that vector to the point. So we have 2, -1, so I'm going to do +2, and we do -1. So 0 + 2 is 2, and -5 - 1 is -6. Then, from that, we're going to do the dilation. So now I'm going to dilate it from the origin with a scale factor of 1/2. Since it's coming from the origin, all I have to do is just take it, multiply it by 1/2. So times 1/2. So let's see, 1/2 of 2 is 1, plug that in, and 1/2 of -6 is -3. And let's submit our answer and see how we did. Yes, I am sure. And we got it right. Always start with the rightmost transformation and move to the left. We'll do another one. Alright, so just to look at this. So again, we start at the right and move to the left because we want to do this is a reflection over the x-axis. So we're going to reflect the translation, a reflection of the translation. So the translation comes first and then I'll reflect that. So my translation is just -4, -3. So -4 -3. Well, let's see, -8 - 4 is -12. And -8 - 3 is -11. So it puts me there. And now I'm going to do the reflection over the x-axis. So the x-axis goes this way. I'm just bringing it down like that. So the only thing that changes is the y values. I'm not moving to the side any. And if you recall, all you do there is the y value changes signs. So if it was a negative, it becomes a positive. So my x value stays the same, -12. And my y value changes to a positive because it changes signs. And we submit. Yeah, that's good. And we're good. So let's just do one last problem here. And what is the image of point 8, -1 after the transformation D4, so a dilation with a scale factor of 4 of R180. So this is going to be a rotation 180 degrees about the origin. Remember, we are going to go counterclockwise. Always counterclockwise, unless it says otherwise. So, which one do we do first? We do the rotation first. Start with the rightmost and move this way because we want to do a dilation of the rotation. So I have to have the rotation to do the dilation. So, rotation 180 degrees. The rule for that is negative x, negative y. That's the rule for that, so that's what I'm going to do here. So that's going to be the negative of 8 is negative 8, and the negative y. So the negative of negative 1 would be a positive 1. So that takes care of the reflection. Now I'm going to do the dilation. And d4, that means I'm going to dilate with a scale factor of 4. So all I'm going to do is I'm just going to take this times 4. So let's type this in here. So negative 8 times 4 would be negative 32. And positive 1 times 4 is just 4. And let's submit this and see if it's right. Yes. And there it is. All right. So hopefully that helps. If you have something like this, remember you're going to go in the order right to left, because this one's a dilation of the rotation. So you have to have this thing first before you can do this one to it. So that's a little weird. You're going backwards like that. Just do the one thing, then do the other thing. Just use your transformation rules. And remember, when you're doing transformations graphically, always do the translation last. Always do the slide last. Do the dilation first, then do the reflection, then do the rotation, then do the translation. Always do the translation last. The other three, you can actually mix them up, we saw, and it didn't matter. But the translation always has to go last. All right? Hopefully you found that useful. I will see you in the next video.